Hello, welcome back to my YouTube channel, guys. Today's question is remove duplicates from sorted array, the part 2. Now you can read the question and description. I just gonna explain you the example. Now in this we are given nums of array, and this array contain 3 1 and 2 2s and 1 3. So we now have to ignore two same element, but if there is three same element, then we remove one element from it, and then we return the length of the array. Now what we're going to do is we are going to declare our temporary variable as the empty list for n in our nums. We check if our temporary count is less than 2, temporary count of n, sorry guys for that, is less than 2, then we append our temporary with the n. That's it. Now for I in range length of temporary, a nums of I will become temporary of I, or we say temp of I. Now we simply return length of our temporary temp. Let's run the code, and we see we are getting accepted. But this is our brute force approach, so I guess it will not work and gave us the runtime error maybe. Oh, not runtime error, but it is not efficient, as you can see guys, getting very low complexity, but it is getting good space complexity, but it takes extra space. Now the better approach will be count based approach, and for that we are going to do define our ln as length of nums, and I is equal to 1, and we initialize count as 1. Now while our I if less than n, then we check if our nums of I is equal to nums of I minus 1, and then our count will be incremented, sorry, by 1, not by 2. And then we check if our count is greater than 2, then we pop our num, then we pop our I, and decrement our n and also our I. In the else case, we declare again our count as 1, and and outside of the if else statement we increment our I and return our length of nums, or we can say n, because we define n as length of n nums. So we can see cases are accepted. Let's submit the code. This code compromise the complexity of O of n square. So you can see we are getting little bit, not little bit, much good complexity compared to last approach. Now let's jump on to the third approach, and that would be most optimal approach, and it is going to be implemented with the two pointer approach. Now for that, what we are going to do, the base case will be if n is greater than equal, if is less than equal to 2, then we return our length of nums. Now we define right as to the first two element always allowed, that we know. Now for read in range 2 comma n, if our nums of read is not equal to nums of write minus 2, then what we do, we declare nums of write is equal to nums of read, and we increment our write by 1. Then we simply return our write. Here guys, write and read is our two pointer. Write is our one and read is our another pointer that we are using. Okay, sorry guys, there is if length of nums. Yes, now I guess it will work. Oh, sorry again. Length of nums. I remember that n from the last approach. Sorry for that. See, this is our case getting case accepted, and this is our most optimal approach. Let's submit that and see the time decrease by 20-30 seconds, something like that, but we are getting good space complexity because we are using in space. So that's that. And the complexity, let me write it for you. For the brute force is going to be big O of n square, obviously, and this is the time complexity, and for the space complexity for the brute force is big O of n. So that's that. And the better approach is that cost us big O of n square again, but the space complexity is big O of 1. And now for the most optimal is big O of n time and big O of 1 for space. Now this is our most efficient and easiest approach, I would say. So if you like the video, then subscribe, like and share and comment. Thank you.